Hello everyone, welcome back to our SQLite series where we're already in video 5 now, where we're going to be covering table schema, join statements, and union statements. So far we've covered a lot, and just to quickly go over what we've already gone through is we looked at getting started, such as how to actually create a database, create tables, some of the basic inserts and select queries. We looked at some conditionals and extra kind of query stuff, working with CSVs as well. We also looked at subqueries. We looked at the aggregate functions like count and sum, looked at limit, distinct, all kinds of stuff. And then also in our last video, we looked at handling null data in SQLite. And in this video, we're going to be covering how to actually use or get introduced to primary and foreign keys and how they relate to the join statement. And in order to do that, we're going to be using an external database from Harvard's CS50 course, which is going to be like a IMDb-like movie database. And with this, we're going to be looking at not just join, but also union and union all, and a brief introduction into duplicate data as well that'll come in. So first, for the database setup, so you guys can actually pull it and work with it. If you haven't followed the other videos, this video will work just fine for you because it's a brand new database. But we're going to run wget followed by the URL for actually getting the zip file. We'll unzip the zip file and remove the zip file. And then we'll go into that folder that we just unzipped, and we will start our SQLite server on the movies.db. So you can see here, we're now in SQLite in our movies.db, and we first want to, as always with tables or databases we haven't seen before, we want to see what's actually in it. And we already know that we can run .tables to get the tables that are in it, and we can do our select star statements and see kind of just the first 5 rows of each of the 5 tables that we have, as you can see here. But also, if we want to get a deeper look at what's actually in these tables, such as the data type, even though we might be able to kind of figure out from the start, there's other stuff that we might want to know about how the table was created and what just all goes into it. And that's where schema comes in. And table schema is basically, if we run the dot schema and then followed by the table name, we're going to get the SQL command that would be used in order to create the same exact table. So basically it's what whoever created the table would have run to create it in the first place. We're going to be able to see what that query looks like. And what that gives to us is some stuff we've already seen before. We see that it would just be a create table, the table name is movies, and then we see our columns as well as the data type. So we see that in this movies table, we have a ID column, which is going to be an integer. We have a title column that's text, and it doesn't allow null values. Year column, that's numeric. And then it notes that the ID column is going to be an actual primary key column. And we'll discuss that in a little bit. Another way that we can look at kind of table schema or to get a grasp of what our tables actually contain is by using the pragma SQLite command. And specifically the table_info function within the pragma command, and we're going to run that on the actual table name. So you can see here we run pragma, table info, and then the table name, which is movies. And what we're going to get is kind of a new table that essentially summarizes the table itself. And you can see that this first column is going to be just a automatic column index that is automatically added by SQL. Second column right here is the name of the actual table column. So you can see ID, title, year. That matches up here with the ID, title, year. So that makes perfect sense. Third column is going to show the data type. So you can see second column is the actual name. Third column is the data type. Fourth column is going to say whether it contains null data or not. And so that name of that column is not null. And it's going to be either 1 or 0. So you can see 0, 1, 0. Now, why is our title column 1 for not null? Well, let's look here. Look back at there we go. Title, text, not null. So this means it does not allow null values, but the others do. So you can see that if the column does not allow null values, it's going to be a 1, kind of like a true. And if null values are allowed, it's going to say 0, meaning that the ID column can contain not null values, although technically it can't because it's primary key, but we'll see that in a little bit. The year column also is allowed to contain null values, but this title column can't. Fifth column is going to show any default values that are set. So we'll discuss this later in constraints, but basically what we're allowed to do when creating tables is we can say, okay, if a null value was in a certain column, we want it to be default to a certain value. And if that was the case here, we would see actual values for what that default value was set to. And then lastly, we'll see if the primary key, or see if the column was actually a primary key. So we see that our ID column is a primary key, so this shows up as 1, and these others show up as 0 because they're not primary key columns. Now to just talk a little bit about like what primary keys and foreign keys are without really diving too deep into them yet, which we'll do in later videos, probably the next one actually. We first just want to know what a primary key is. A primary key is a identifying number or integer ID value for an actual row. It's essentially a unique way to identify an entire row in a table and just like one row at a time. So you can see that this here, that there's only one, that this ID of 1 can only appear once, and it's going to identify this entire row. 2, 3, so on. You see that here. And we also see that there's a primary key being used in both, we talked about the people, and it's also used in this movies table. You can see the same kind of thing. These are all primary keys. And this primary key is not going to show up more than once. It's only going to show up once in that table because it identifies that entire row. Now, what can we do with these primary keys? We can kind of combine them with what's called a foreign key. And these foreign key columns, which in this table, you can see here that the movie ID and person ID column are being told that they are foreign key columns as well. So what this means is that what's contained inside of these foreign key columns is actually the primary key of another row, of like a row in a separate table. So you can kind of see here how they match up. We have, okay, this foreign key column right here, 11801. Okay, this matches up with the actual primary key of this row in the movies table. You can see here, and it's the same thing here. 13274 matches up with the primary key right here. So essentially what's going on is the foreign key in a separate table is referencing that it relates to an actual, like another row in another table. It's really creating a relationship between different tables using a certain primary key. And it's just that foreign key that denotes, okay, what's in this column will be a primary key that is contained in another table. And we're going to discuss this kind of primary key, foreign key stuff in later videos. But for now, that should be enough to just barely dive into them and then kind of learn join statements. So the question that we're asking now that we kind of have the table schema and what the table's all about is I'm going to ask, who was in the movie Kate and Leopold? Okay, we can go about this in a bunch of different ways, and we want to go about this kind of the manually way first before showing how we can utilize join, union, and some other statements. So how might we go about this manually? Well, first we ask the question, what is the movie ID for Kate and Leopold? So we can kind of see here, we're trying to figure out what the movie ID is, and it makes sense that, okay, we have this ID column in our movies table that also has titles. So we're essentially kind of going from the title, which we want this to be Kate and Leopold, and we're going from that to the ID. In order to do that, it's going to be stuff that we've already seen before. We're going to select the ID, so that's what to show, from the movies table where the title is Kate and Leopold. What's that going to give us? It's going to give us 35423. So essentially it's going to be 35423 that shows up in this ID column where the title is Kate and Leopold. Okay, we have the ID for the movie. Now we can ask, okay, what directors or what person IDs have this movie ID in their table as well? So kind of going back and looking at our table, let's look at the stars and the directors. We see that these directors, they have a movie ID associated with them, and so do the stars have a movie ID associated with them. So we're essentially seeing where this movie ID in the stars and directors table is equal to this 35423 ID that represents Kate and Leopold. So we can run that actual query, and all we're doing is kind of similar to what we just did. We're selecting the actual person ID where the movie ID is equal to 35423, which represents our Kate and Leopold movie. What does this give us? Okay, we have the list of the person IDs like stars. So this is, think back to our stars table. We have our ID list where the movie ID was 35423. And these are like the people IDs. Okay, well, great. We can also do that on the directors table, and we get that their person ID is 3506. All right, now that we have all of these IDs, these are people IDs. So these people, like these IDs, are associated with being in the Kate and Leopold movie. And we now want to go to actually getting what their names are. Okay, so what are we going to do? We're going to look at, okay, we have our IDs. We want to look at, let's look back at our tables. We see that in our people table, we have IDs as well. Okay, we have these IDs. Now we want to go from the ID to the actual name of the people that matches that ID. So let's run that query. Select name from people where, and then we're listing out, you can see here, all of the IDs. So these IDs are matching up to what we got manually. And you can see how this is really annoying to write. And luckily we're going to show how to kind of automatically do this later, so we don't have to type so many or statements to get the names of the people in these movies. But if we run that for now, we're going to get the names of the people that were in the movie Kate and Leopold. Okay, we answered our question. But that took some time. So we want to look at how we might be able to do this more, I guess, automatically or all in one query. How might we do that? Well, we're going to introduce what's called the join statement. The join statement is going to allow us to kind of join like left and right together, tables together by like rows that match up. So as we talked about the primary and foreign keys earlier, this comes right back into that. So if we want to, we have one table that has a primary key, a bunch of all their other data in a row. We want to also find the other table that has a row with the foreign key that matches the primary key so that they can be kind of like squished together and match up together. And to do this actual join statement, it's select star, so get all the columns from the people table, join stars. So you can see stars, this is the table 2 that we're joining, and this is the other table, so people is going to be on the left, stars on the right. We're joining these together. What are we going to join them on? So this is what's related between the tables is really what we're asking here or answering. People.id. So this is the people table and the ID column. So this would be like this. Equals stars. This is the stars table. And within the stars table, the person ID. So look at here is this people.id, that's the primary key. And the person ID column in the stars table, that's our foreign key. So that's what we're saying to match up on. So Our final rows, if you think of it all as one table now, is the ID, the people.id column, and the stars.person.id column is going to be where they like equal together. So that's really what is going on here. And you can see that these kind of get squished together. But that's pretty cool. And here I just kind of showed how we're matching how you can see how these match up perfectly. They have the primary key of 681726 matches the foreign key of 681726 in our stars table. You can just see how perfectly they align together and created, using join, one entire new table. Great. Now we're going to also do, or I guess this I just kind of wanted to point out how we can combine 3 different tables together. And it's a very similar query. You can see here, this is basically the exact same of what we just did. And we're also going to join on the movies table. So now it's not just the people in the stars table, but it's also the movies table being joined on. And this movies table has the column movie ID, and that's the primary key, and the foreign key, which was in the stars table of column movie ID. So you can see we have our 3 tables. We have our people, stars, and movies. And we're going to join these all into one table. So now we're taking, instead of 2 tables together, we're joining 3 tables together. Great. And this is our resulting table right here. And you can see how the ID matches, or how the movie IDs match up with the ID in the movies table, and how we're just, these rows, because of these primary and foreign keys that were in them, we're matching all these rows together and getting one new table that we can work with. Now that we have this entire new table, which it's not like an officially like saved table, but it's going to be part of our query that's to come, is now we have this big table that's all together. Now we can just find where the movie equals Kate and Leopold. And all we did here is add on the where clause, where the movie column, its title is Kate and Leopold, and it returns to us from this like imaginary table that we created all of the rows where the title is Kate and Leopold. Now what would we do from there? It's pretty simple. Instead of selecting star, which is like select all the columns from every single table from all the resulting table, instead of selecting all the columns, we're just selecting the name column. And what we get is, instead of this whole table, it's working with this whole table, but all it's returning now is the names. So these are all the names of people that were in Kate and Leopold. But here, we've only done the stars so far. We haven't like added the directors in. So we just have a list of the name of the stars. How might we add the directors in? Well, you can think of it that our join statement was squishing tables together kind of like horizontally or left to right. But if we want to add onto our resulting table also the directors, now instead of like left to right joining, we're really like stacking rows on top of each other rather than columns side by side. We're stacking rows on top of each other. How are we going to do that? Well, that's what's called a union statement that'll allow us to stack rows on top of each other. So here, this is what we already just did this. This is the exact same query that we just did. And instead, we're also going to union, which means we're going to stack on top of each other, the directors as well. And you can see that this query, it's almost it really is the exact same kind of query as this that we did up here in joining, except this time, instead of doing the stars, it's the directors. So we're joining the directors table on this time. And here you can just see that we're using an alias to say whether they are a star or a director in our resulting table. And what's this going to give us? Bang! Perfect. We have the names of all the people that were in Kate and Leopold, and we have their role thanks to our union. So this guy was a star, director. And see how we were able to put the rows on top of each other with union. Pretty cool. Now, this gets at duplicate data and how union works. Union on its own is going to automatically exclude duplicates. Those are not going to be included on top of, they're not going to be like stacked in the resulting table. There's not going to be duplicate rows. And what is a duplicate row? It's where the entire row is identical. And let's show this here. I ended up making two different tables called dups1 or dups2, duplicate 1, duplicate 2. You can see that in these two tables we have our IDs and name column, and kind of different variations of how I wrote out like the ID and name. Let's see what would happen if we unioned these together. Okay, so remember we're stacking these tables on top of each other. What's being stacked and what's not there? Okay, we have the studious with the ID of 1, 2, ID of 2, lowercase, the studious. Remember, this is going to be case sensitive for these duplicates. We have the row 3, all caps, name studious. We're not row 3, but ID 3. We also have an ID 3 again. So note here how the duplicates have to be exactly identical rows. So even though these are duplicate IDs, it's still going to work because they're not identical rows, essentially. But what's not appearing here, or what seems to be a duplicate? 2 studious. So wherever the ID is 2 and name is studious with all lowercase, this is only appearing once. So we can see here that duplicate data, it's, okay, I guess not exactly excluded, but it's only going to show up once. It's only it's not going to show several different times. It's only going to show the possible outcomes. We kind of talked about this earlier with how you can only have heads or tails. It's only going to show the possible outcome once. It's not going to show them the repeated coin flips like we talked about in earlier videos. But if we instead use union all instead of just union, this is just going to say duplicates are perfectly fine. We want duplicates to show up in the end result. We see here, of course, there's going to be all the rows from each of the table. And this really shows how union kind of works in general, how these two tables were stacked on top of each other. You can see how it allowed duplicates this time. That showed up. So you see ID of 2 and name studious, ID of 2, name studious. Duplicates were allowed. And again, I want to emphasize that in SQL, duplicates are exactly identical. All of their columns must be identical. All right, this kind of wraps up the video on join and unions and a glimpse to duplicate datas. And in the next video, we're going to be talking much more about constraints and really relating data in general. And if you didn't understand primary and foreign keys in this video, they're really going to start to make sense in the next video where we go to actually implement primary and foreign keys ourselves. So I hope you all stick around because we're getting close to the end, at least to the point where we can start doing some really cool stuff and what SQL is meant for. So thanks for watching, and I hope you guys tune into the next one.